before we start, I would like to ask you a couple of questions. First of all, who in here knows what JUnit is? Could explain it? Okay. Well, I think at least you know what it is, kind of. So JUnit is a Java testing framework, right? So you write tests using Java programming language. So you have to know how to code to write those tests. And in this presentation in particular, we will see a lot of code. So this is really a technical presentation about this tool, JUnit. And yeah, just be warned. The screen is not as big, so in case you can't read something, please tell me or come closer to the screen. Yeah. Okay, before we start, a couple of words about me. So, well, my name is Marc Philipp. I work as a software engineer in Germany for LogMeIn. I've been a JUnit maintainer for some time now, so I started in 2012, kind of by accident, and have been that then ever since. If you have a question and you don't get to ask it here for some reason, feel free to ping me on Twitter. I also have a website, but it's not really, there's not much there, so. But just in case you don't want to use Twitter. All right. Without much further ado, I will jump right into some code. So we don't just have to listen to me, but you can also look at some code. I often find that to be very helpful. So I'm going to give you a demo of the new programming model that JUnit 5 provides. So in order to do that, the first step is I have to have a new dependency in my project. So this is a project where it's a Cradle project, but you can use it with Maven or anything, where I already have some tests. For example, this is a simple JUnit test. So it doesn't do much. It asserts that 1 + 1 = 2, right? So the simplest possible example. And we have a second test that is ignored, and the comment is for some reason, because it won't work. Yeah, so that's a JUnit 4 test. But I want to use JUnit 5, and in order to do that, I need to add an additional dependency here. So I'm just going to add the JUnit Jupiter API artifact here to my project. So that's all fine. It's now added, and I'm just going to show you how to change this test from being a JUnit 4 test into a JUnit 5 test. And keep in mind, this Jupiter word is the new word for the new programming model in JUnit 5. All right. So I'm just going to do this manually now. IDEA is already smart enough to do it automatically in this simple case. But just for demonstration purposes, I'm going to do it on my own. So I'm just going to remove all these imports from org.junit. Now everything will be red, and I can import the new classes. So one thing to note here, everything in the Jupiter API is in the Jupiter API package. So that's one thing. So you move from org.junit to org.junit Jupiter API. All right. The same thing for assertions. They used to be from the assert class. Now there's an assertions class. And it's also in the Jupiter API package. So you have to import. Assertions now live there. One thing to note for ignore, we have really thought hard about all the names. And this is one of them where we didn't really like, so we changed it into disabled. So this test is now not ignored, but it's disabled. And you're really encouraged to specify the reason why that is, right? So you shouldn't just disable tests randomly and then give your colleagues a pointer why this is disabled. So this is not a good example. Okay, one other thing to note is we can get rid of all this public stuff here. So we can remove all the public modifiers. We don't need them anymore. So that's kind of where we've decided, okay, let's make it a little less boilerplate. I know Java developers are used to boilerplate code, so still, the less of it is the better, right? So I can still run this, and yeah, IntelliJ IDEA already knows how to run JUnit 5 tests, so that's easy, right? Still, the one test is successful, the other one is skipped, and you can read the comment here that comes from here. So that was a very simple example, right? Let's look at something more complicated. Okay. We have, let's close that as well, assertions demo. So this is about assertions. Yeah, JUnit 5 still has only basic assertions included. So we have deliberately decided to do that because there's already libraries like assertj or hamcrest or truth that really provide very, very good support for assertions. So we didn't want to reinvent the wheel. And, but at the same time, we didn't want to leave you blank without any assertions by default. So there's still this assertions class. I showed you that already. So we can now just go ahead and do this manually once again. I'm going to remove all the existing imports for assertions, and I'm going to re-import them from the new place. Yeah. So I'm going to take a shortcut here and just import all the assertions. All right. So this almost works now in the first test here, with one exception. This one is not resolvable. That's because in JUnit 4 it was always kind of weird. If you had a custom failure message you wanted to show when the test failed, you had to put it in the first place in the argument list. And we found that it's not following the convention that optional parameters should go last. So we changed that. So now it just should go last. That's one of the changes we did. That might break something when you migrate the tests. But then again, the tests are run, right? That's what tests are for. And you will notice. And those few cases where you have checked strings, you will find. All right, another addition is that we have now support for suppliers. So a supplier is simply a Lambda expression. And if you want to compute a failure message that gives you a lot of information, for example, about the environment this test is run in, this might be something that is expensive to compute. And then you can only, since you only need it in the case the assertion fails, which is not the usual case, right? Usually your test should pass. You don't have to compute it every time. So this is what a supplier comes in, which is a simple pattern from Java 8 that lets you only do things when you need them. So in this case, it doesn't really make any difference, right? Even if I write this like that, the compiler is smart enough to only do this once at compile time. But if I had some more expensive computation here, it would help me. I would save some time. All right. Moving on to hamcrest. Who in here has used hamcrest before? Okay, a few people. Yeah, so hamcrest is something that JUnit 4 depended on. So it was a real dependency of the jar file, and that brought some problems with them. So for example, if you have wanted to migrate to a new hamcrest version, you had to wait for JUnit to pick it up. And since JUnit is not the fastest moving project in the world, this took some time. Now we've decided we don't want to have any external dependencies, which is why the assert that method cannot be found now. It's not in the assertions class anymore. But that's not really a problem. You can just import it from the matcher assert class, which comes with hamcrest anyway. So just hamcrest now is like any third-party assertion library that you might use. Same for assertj. You're just going to use it directly without going through JUnit first. So you can still use it, just have to import it from a different place. All right. Then we come to a little bit more complicated example. It's the error collector. Who has used that before? No one? Okay. I'm going to tell you what it does. So basically, a regular assertion like this one, if that fails, none of the remaining assertions would get executed. Error collector is a way to check for multiple things and always check for them. So in this case, these two checks here would always get executed. And you will get an error report in the end that tells you which of those have failed. So in case you have an integration test or something that takes more time to run, this is useful because you have more information when it fails and don't need to rerun it just to get to the next assertion. All right, so I'm going to change that because we don't support rules anymore in JUnit 5. It's not a thing. I will tell you in a second why. But we have something else. We have assert all, which does basically the same thing. Yeah, you just can use assertions directly. You don't have to learn any special syntax. just this assert all thing, and it takes a list, basically, or an array of lambda expressions. And yeah, what that does is you can use anything to check for something. You can use any assertion library. We don't care. And this will do the same thing. So when I execute that, you still will get multiple failure messages, right? This is 2. And you can still read all of them. So that's the same functionality, but it uses a Java 8 language feature, not some magic in the background. All right, moving on. Please stop me if you have any questions, right? So you can ask at any time. I'll stop. Otherwise, we can always discuss later when I'm around. So the next example I prepared is this lifecycle demo. So yeah, you have all these lifecycle callbacks in JUnit 4. There's before class, which has to be static. It's something that's executed once per test class. We have before, which is executed before each test. Same for after each test. There's the after annotation, and there's after class for doing something after all the tests have run. And I'm going to migrate this test manually as well now. So let's just remove all the JUnit imports. As I said, rules are not something we support anymore, not really. And yeah, test we've already seen, can import that from the new location. Okay, so that's good. Yeah?
Have you created an automation script to replace all imports just automatically?
Well, actually, IDEA has already started in that direction. So a simple test, it can automatically migrate. Oh.
I don't.
The question was if we had some automation script. I can just repeat it.
The question.
If that's, I mean, you can restate it if you want, but okay. Yeah, we currently don't provide any means of automating the migration, but that's something IDEs will do, and IntelliJ has already started doing it. So they have already a bunch of things. They can automatically replace assertions and convert simple tests into new tests. And this will improve, we think, and we're pretty sure it will, once we have shipped the GA version of JUnit 5 and all that. So I'm just doing this now to show you the differences. I'm not telling you have to do this on your own all the time, and this will be the next 5 years of your life. No, that's not what I mean, right? So I'm just wanted to show you the differences by converting it. So yeah, I said previously we thought hard about the names, and this is also a case where we changed them. You can already see it by the method names that I kind of hinted towards that. So before class is now called before all, and before is called before each. We think these are much clearer names. That's why we changed them. But they do basically the same thing. Just new names for them. Okay, assertions, as I said, come from here. All right. So I have 2 red spots here still. This test name thing was a rule, a JUnit 4 rule. But now that's not a thing anymore. But a new thing that we have in Jupyter is we can now inject parameters into test methods or into before each methods for that matter. And there's already something that's called a test info that you can get by default. You don't have to do any special thing to get it. So we can just test info, get display name, and yeah, get the display name of this test. And the same thing down here. But we need to declare the parameter. So, and we can remove all this public stuff again. Well, okay, let's do this like that. All right. Run it, and as you will see, it still prints before all once, after all once, and then before each, after each, for every test case. All right. So that's just to show we still have lifecycle callbacks. One new feature I wanted to show you is we have now something that's called a display name. So yeah, when you look at the, just get one step back. When you look at the tree in the IDE, you get this 1 + 1 is 2. That's the method name, right? And you can be very explicit in your method names, and they get really long. But it's not always that readable, right? You can use camel case or underscores or whatever, but it's not the best thing in the world. Sometimes you just like to write 1 + 1 = 2. And you can do that now. So this is just a custom display name. It allows you to specify that more clearly. And you don't have to do this for every test, but sometimes it makes sense. It makes things just more readable in the report. But, yeah, one thing I should mention is you can still navigate to the test from your IDE. So this information is still there. It's also one thing we took really good care to provide all the information now in the new JUnit 5 model that the IDEs and build tools might need. Okay. What else do we have? Exception testing. Just a second. All right. So in JUnit 4, there's actually 3 ways to test for exceptions. There's the old school approach here, where you just write a try-catch. In case your code does not throw an exception, you fail the test manually. In case it does, you catch it, and you can assert something about the exception. For example, in this case, we check for the exception message, yeah, to be some certain string. This is kind of verbose. So JUnit 4 introduced this expected parameter here for the test annotation. And lets you specify the class, right? And then you can write any code in the method body, and that code is supposed to fail, to throw an exception, and the test is supposed to fail if it doesn't. Which is kind of nice, kind of short. On the other hand, you cannot assert anything about the properties of the exception. So if you needed to check for the message, you could either use the old school approach again, or use something that's called expected exception, which is a JUnit rule that lets you specify what you expect and then write the code here in the method body. So that's the third way that was introduced in JUnit 4.7. And this is kind of confusing to have 3 ways to do essentially the same thing. So we added another way. And I'm going to show you. And this is the only way you will need in the future. So that's why we added a new way. Okay. So the new approach looks like this. So basically, it's kind of like this, yeah, but it's a new assertion. It's called assert throws. And I need to import that from the assertions class. And the first parameter is the exception that you expect. So it's just a number format exception in this case. And then comes the block of code represented as a lambda function that you expect to throw an exception. In this case, it's just integer parse int for some string that's not a number. Okay, that's basically what this does. Yeah, it checks that there's an exception thrown. If you need to check some properties, you can simply assign the return value of this assert throws assertion, and then use any means to assert, for example, the simple assert equals here. So this is just using a new way in Java that lets you write basically an anonymous class, some code block in an easy way, and we've made use of this here to make it simpler for you to write that. And this is the only thing you will need. There's no special framework magic. This is even working with JUnit 4, so it's pretty simple. And we think it's better than all the existing approaches. So we can get rid of all this and just use that. All right? Good. So what else do we have? Yeah, I know this one. Okay, who has used parameterized tests before? Okay, again, a couple people. Huh? Okay, not in JUnit. Yeah, well, I'm going to make a point that it's kind of complicated to do it in JUnit 4. So this is what it looks like. You have to specify a runner, run with parameterized. You have to define a public static method that's annotated with parameters and return an iterable of object arrays. And each object array is considered to be one set of parameters. And you can use parameter annotations on instance variables to inject them into your test class. And then you can write tests using them. So in this case, we just bind the first parameters to this string input thing, and the second ones to this base 64 output. So when you run this, you will get 2 test cases basically here, right? So this is kind of a lot of code to write for just executing one test 2 times, which is why we have something new here. Oh yeah, one thing to mention is right now it's still in the milestone phase, so this was an experiment kind of. It still is an extra dependency right now. We're actually thinking about changing that and putting it into JUnit Jupiter API as well, but right now it's a separate package, separate jar. Okay, now I can actually find it and just write this like a regular test. Okay. All right. So instead of using fields, we now use just method parameters. So we can just say, okay, string input, string base 64 output. All right. And you can basically write your method body the same way as before. And of course, you need to somehow specify where those come from, right? There's a new concept, it's called source, and we have a lot of implementations already. I'll show you a list in a second. And one of the very nice ones, I think, is called CSV source. That's you specify, basically comma-separated values, or you can use any delimiter, actually. So I'm just going to use a more fancy one. Let's take this arrow here. So bar should turn into this, right? Okay, so this should be the same thing. And okay, one thing I didn't show you is that this test name can actually be customized. We can do basically the same thing here. We can say, okay, the first parameter should be transformed. Well, let's take the same. No. Let's do it this way. So we can customize the name still, right? And you don't need all of this anymore. You don't need that in particular. You can make this package private. And you can even use the assertion that comes from the assertions class. So now we are 100% Jupiter, and we can run this. And it fails. Why is that? Oh yeah, good catch. Thank you. I should do this. Yeah, okay. Very good point. Yeah. Of course, if you use a custom fancy delimiter like I did, you have to specify it. Otherwise, it's just a comma. Thank you very much. Okay, now it works. Yeah. So now we get the expected output here, and it's grouped differently. It's the actual invocations are grouped under the test method and not on the class level anymore. But it's basically the same thing before, and it's just much shorter. And you can provide your own source implementations and everything. All right, last but not least, JUnit 4 had something that's called categories. JUnit 5 doesn't have that anymore. Instead, we have something that's called tags. Let's migrate that manually. So a category was basically a link to some class that was empty, which is the marker class. Yeah, there's a question?
Yeah, sorry to interrupt you.
Sure.
So, question about the previous example,
okay,
these parameters, and can I use not only static values, but maybe functional results?
Yeah, you can. I will show you. I have a list of all the currently implemented CSV sources, or source implementations, I should say. Okay, let me just finish this one. Yeah, now it's all red. Yeah, so JUnit 4 had categories, so we could categorize your tests and only execute a certain category, for example, or exclude a certain category from being executed. JUnit 5 has basically the same thing. It's called tags now, and they are string-based. So you don't have to have these empty classes here, right? There's nothing in here. anymore. Which makes it a bit easier to use those across projects, for example, the same kind of categories. You don't have to think about where to put those classes. So we don't need them anymore. Okay, so this basically tags this test, which is not useful in itself, but you can execute a specific tag only or exclude a tag from being executed. This is where this makes sense. All right. That was the demo. Oh, by the way, it's all on GitHub, so if you want to look at any of the code, that'll be right here. I will commit it and push it in a second.
Sorry,
yeah.
Tag is test specific only, or it can be a test on a class?
It can also be on a class level, yeah. That will. The question was whether or not tag is test specific, but no, it can can also be applied to the class level, which will then tag all the tests in that class accordingly. Yes, good question. All right, one thing I did not show you were meta annotations. So all the JUnit 5, JUnit Jupiter annotations can now be used as meta annotations. That is a means to combine annotations. So in this example, you could, in your project, declare an integration test annotation, for example. And yeah, you have to specify the target and retention. But then you can apply any of the JUnit 5 annotations to your own annotation and use your own annotation in your project instead. So the usage at the bottom, instead of writing tag integration and test, you can just write add integration test. And this can be done with any of the annotations. Just keep that in mind. It will, later when I show you extensions, it will also be particularly interesting because you can do lots of things with annotations then. Okay. Now we come to your question. These are the sources we currently provide, they can currently use with parameterized tests. We have seen the CSV source, but there's lots of different ones. So there's value source, it's a very simple thing for just literal values for a single parameter method. Same with enum source, just all the enum constants in an enum. But there's also method source, which lets you specify the name of a method in your test class that returns the values. So you can actually use those for multiple tests, parameterized tests. There is CSV source, but you can also use CSV files. So CSV file source has you covered there. You could just implement an interface that's called arguments provider and specify that. That's the argument source annotation. Or you can come up with your own kind of way to do it by providing your own custom annotation and just annotate that annotation with @argument source and specify your provider. That is how all these are actually implemented as well. So this is really extensible. These are just the ones that are most general purpose, but you could also provide your own implementation, for example, that reads from a database or, I don't know, stuff, really, whatever you can think of. Another thing I did not show you, I think the code is now a bit small here in the slide, on the small screen, is nested tests. A nested test basically lets you group a bunch of test cases and give them a common setup or tear down, and you can arbitrarily nest them. So you can, in this case, we have tested a stack, and on the outer level, the stack is just empty, right, but new, and in a nested class inside this nested class, we can add additional setup. For example, we push an element to the stack, and all the methods in this test class now can build on that setup and check what properties the stack should have if it has one element. Yeah.
Could you just add the message to it, add nested annotations, so that we don't need to specify additional annotation?
You mean the display name? Oh, yeah, okay. Well, right now we cannot, but you can, of course. You could specify, if that's a really common use case, we can think about it, yeah. Yeah, but I mean, in this case, we combine the two features, and yeah, it would be less verbose to just have it as nested. Yeah.
How about Eclipse and NetBeans? Does this idea support this feature? Or
Well, yeah, I will come to IDE support in a second, so we'll discuss that actually. I'll postpone the question for now. That's fine. Okay, another thing are dynamic tests. So far, I've only shown you static tests. So what I mean by static? Well, usually you compile a test class, you know exactly which methods are there, you know which methods have the test annotation on them, so they're statically known at compile time, basically. On the other hand, dynamic tests are something that just happens to appear at runtime. So instead of annotating the method with test, we use test factory and return a stream or iterable or collection or something like that of dynamic tests. And then in the method, you can use any code you want to somehow generate that stream. And in this simple example, we just generate an int stream of all even numbers, limit it to 100, and then map each of these numbers to a dynamic test. And this dynamic test method here is just a static import, and you have to give it a name, which we built here. It's just test plus n, so it's just test 0, test 2, and so on. And then you specify a lambda expression. Basically, that is what you would put in the method body of a normal test. And this looks like that. So if you execute this in IDEA at the moment, IDEA has no clue whatsoever how many tests there will be, because it cannot. We don't know that up front, right? And as tests are returned from the stream, we report them, and IDEA shows them in the tree. So this grows with time. It's just a very, very flexible way to somehow come up with your own way to come up with these tests, load them from somewhere. And this will even be extended in a new milestone. All right. We also have repeated tests now since M4, so you can just repeat a test multiple times. For example, if you have a flaky test and you want to make sure that it's now fixed, you can just try to execute it a bunch of times to see if it works now. Of course, that's not 100% certainty, but still, you can repeat it. Yes. So that was the first introduction into the programming model. So I didn't want to talk that much without showing any code. But you have a question. Okay.
Is it possible to make this dynamic so that you pass the parameter about how many times you want to run the test?
Should I repeat? Can we make this dynamic so that we pass the parameter how many times to run the tests?
Well, I'm not sure exactly how you would pass the parameter, but I mean, this is all implemented based on an extension point. So if this is too simple for your use case, you could also implement that as your own extension, kind of. So the extension point is called Test Template Invocation Context Provider, which is rather long. It's the extension point that we use to implement repeated test and also parameterized test. So basically, if you have something that looks almost like a test, but it's invoked multiple times, that's the extension point you could use. And you can determine that dynamically then, yes. This currently is very simple. You have to have it node statically.
Sorry, not really related, maybe. Do you, test unit, have a multi-threading or running annotation? I mean, I want to catch more multi-threading bug. What should I do? I believe I wrote myself some parallel runner for this case. Is there something new for this?
Currently, we don't have that. There's an open issue to provide parallelized support, but at the moment we don't have that. So it's kind of, because it's really kind of dependent on exactly your scenario. So it's really hard to get this right in general. So I have 15 minutes left, so I'd like to continue. Okay, I wanted to tell you real quick why we actually needed a new JUnit. So now I've shown you some of the features. You might ask yourself, why didn't you just add them to the existing JUnit, right? There's a bunch of reasons. First of all, JUnit 4 does not have a coherent extension concept. There's actually two. So there's runner. You can use the run with annotation, as we've just seen, with parameterized. And it's very powerful. A runner can customize almost every aspect of test execution. It can even have its own understanding what a test actually is, if it's even a method or something else. On the downside, you can only have one runner per test class, right? So it's not composable. You can combine, for example, You want to execute some tests using Spring dependency injection, and it should also be parameterized. Well, you can't do that. So that's a really strong downside to using runners. Then we have rules, which is an extension mechanism that was introduced later, JUnit 4.7. Basically, a rule wraps around the execution of a test or a test class. And yeah, you can execute any code before that, after that, that kind of thing. It's really great for simple use cases. So you can, have your setup externalized in some class, reuse it across test classes. That's nice. However, a single rule cannot act on the instance and the class level. So that's kind of a really strong limitation. And yeah, so we didn't really think that we could build on that extension concept. There's another thing that's really hard if you're a library maintainer, is if you have a lot of people using your library or your testing framework. This is the top 20 libraries used by GitHub's most popular Java project, and JUnit is, of course, very high in the list. So yeah, a lot of people use JUnit, that's a good thing, of course, but on the other side, it's really hard to change anything. I'm not talking about public API changes, I'm talking about implementation details. So, like this one here. Yeah, so even renaming an instance variable is not something you can just do. Yeah, so we did that in JUnit 4.12 beta 1. We thought, okay, this F prefix, that doesn't look nice. We don't do that anymore, right? So let's rename that. And we did, and we broke Gradle, basically. So, yeah. I mean, this is our own fault, not Gradle's in this case, because we just forgot about serialization. But yeah, still, it's really hard to do anything if you are that constrained. And this all comes from the existing architecture of JUnit, which is, yeah, it's a pretty simple project when it started. It just one jar file, and then it grew a bit. And the jar file now includes the old version and the new version, and everything basically is in one jar file. And whether you write a JUnit 4 test, whether you write a JUnit extension, or you are even a different testing framework that wants to run in an IDE that supports JUnit, you can write your own runner to do that. You depend on the JUnit jar, and it's not clear on which parts. And the same is true for IDEs and build tools. They want to display stuff, right? They want to give you good ways to execute your tests. So they kind of had also to access some of the internals a bit, because the API was not, well, that thoughtfully designed, or expectations what the JUnit integration should do grew over time. So this also made it very hard to do anything with it. So in a way, the success of JUnit as a platform for other tools or other testing frameworks prevented the development of JUnit as a tool to write tests in. And that's something we wanted to solve. That's why we came together and are now here, 2 years later, basically. So the design goals for JUnit 5 were, we of course want a modern programming model. JUnit 4 still is compatible with Java 5. So we want to use Java 8 features, not only in the implementation of things, but also in the APIs. And we want to have a coherent, powerful extension model with a focus on composability. In order to do that, we wanted to segregate the APIs. We wanted different APIs that allow you to execute tests and to write tests. But at the same time, we know that a lot of people have large test suites, right? They don't want to jump on a new testing framework and migrate all their tests. So compatibility is really crucial, and we want to provide a good migration path for those people. So to solve that, we modularized our one jar thing very good, and we also had the design goal of no external dependencies whatsoever, no Hemcrest dependency, for example. So this is what it looks like from a very high level. We now provide something that's called the platform. And on top of the platform, we have something that basically is a testing framework. So we have something that's called Vintage now, which represents the old JUnit 4, JUnit 3 style tests. And the new tests, we already saw that, are called now Jupiter. That's the new testing framework programming model that we provide. But this platform at the same time is also open for third-party testing frameworks. So if you have a testing framework, or you have have a cool idea how a testing framework should look like, you can now just basically focus on the part that is really relevant for you and rely on this platform to get support for IDEs and build tools. So there's just one interface you have to implement to kind of make the connection. This is what it looks from the inside. So each testing framework basically now consists of 2 parts. That's the ideal model. In the middle, the Jupiter one, we have an API jar where you actually have to depend on a test compile scope to write tests. But at runtime, you also need an engine. That's the abstraction that you have to implement that knows how to find these tests and execute them. And basically, the platform will ask every engine that's present at runtime to discover and execute tests. And this will just then work without any further setup. You don't have to register your engine manually or something. It just has to be on the class path. We also provide in the platform support for executing tests. So we have a Gradle plugin, we have a Maven Surefire provider, we even have a console launcher that lets you run tests from your console, from your terminal. And to provide you another compatibility layer, we have a runner implementation. Looks like this. That lets you execute a JUnit 5 tests. Yeah, mind the annotation here. It's a JUnit Jupiter annotation. Lets you run this test on JUnit 4. Yeah, so you can execute JUnit Jupiter tests on JUnit 4. This is meant for just as an interim solution for old tools. If you have, I don't know, Eclipse right now or NetBeans or whatever, and want to start writing tests using JUnit Jupiter, this is what you might want to use, right? So we have to have this small annotation here. But you don't necessarily have to do it for every test class. You can also use this JUnit Platform runner in suite mode and just define one of these classes here that doesn't have anything in its body. It just has a bunch of annotations, so we can specify packages it should run, can filter engines you want to run, and have one of those classes in your project, for example, to execute all the tests in your IDE. Maybe your build tool is already smart enough to execute JUnit 5 tests natively. This is meant as an interim solution for old tools. Yeah, as I've said, IntelliJ supports JUnit 5 since a long time now, since 2016.2. There's already Eclipse support available on a branch right now. We have talked, so we are really in close cooperation with them, and we have kind of aligned our roadmap with theirs. So when we follow our roadmap and ship the GA version in August, this should be in time to get into this first service release of Oxygen, which is in September. So starting in September, you will have official Eclipse support as well. Yeah, the rest I said. So yeah, so compatibility is really crucial, and we have this backward compatibility. The vintage engine lets you run JUnit 4 tests or JUnit 3 tests even on the new platform. We have forward compatibility, but the runner lets you run JUnit 5 tests on JUnit 4. Yeah, so extensions are really important. One of the main reasons why we wrote JUnit 5. Registration is done via annotation, so we just annotate your classes. I'm just going to skip this and go to the demo directly, since I'm running out of time. I need to commit this first. Type. Not basic. Come on. Okay. Cherry pick commit. That's the wrong one. Yep, now we should be good to go. We have this extension package. Yes, and one thing I showed you is disabled, but you can also define your own ways of telling when a test should be disabled. And I have just invented my own here, disabled on conference. So I don't want to be called by my boss when I'm on the conference because the tests fail, right? I want to be focusing on the conference. So right now, if I run this, it will fail because I haven't implemented it yet. So this is just a regular annotation here that has a retention of runtime and a target method. And as I told you, you can annotate annotations with annotations. And I'm going to do this here. and write my own extension to do. So by default, extension is just a marker interface that's used in the annotation parameter. In this case, I want to implement the test execution condition extension point, which is one method, evaluate. It gets the context of the test. That, for example, gives you a bunch of information about what the test is called, what's its parent, what tags does it have, what is the test class, the test method, all kinds of things that you would maybe like to know about the test. In this simple example, I'm just going to assume that conferences usually happen on Sunday, which is kind of weird, but okay, let's do it for now. So if it's Sunday, I'm just going to skip this test. And I have to return a condition evaluation result, which is basically a Boolean with a string message. So if it's Sunday, I'm going to say disabled. Otherwise, I'm going to say, okay, it's enabled. Get some work done. Okay, I'm going to run this again. We'll see it's now ignored, it's skipped, because I'm at Heisenbug, right? So I don't want to run my tests. Which is just a simple, very dumb example. But you could use any kind of logic to determine whether the test should be skipped or not. Is a question? Want to have the microphone, maybe?
If I put else meta annotation in this test method, in what order they will be executed? For example, you wrote conditional test, and its meta annotation disabled on conference. If I make new meta annotation and put to this method, in what order they will be executed?
Well, the JVM doesn't exactly guarantee an order. Right now, it's ordered, so we get the order from the order the annotations are declared in, but it's not in the Java language specification.
Okay.
So right now it's in that order that you see. Okay, so I'm going to skip my second example. You can take a look at the code then later on GitHub. These are all the extension points that we have. So we have a lot of test lifecycle callbacks for before all, before each. There's even before test execution callback, which is after all the before each methods. And test execution exception handler lets you post-process the exception. So in case you want to enrich it with some additional information, you can do that. We have the conditional test execution. We've seen that. There's also test instance post-processor, which lets you post-process the test instance. For example, if you want to inject some values into fields, you can do it using test instance post-processor. There is parameter resolver, which I would have loved to show you, but I'm running out of time. Basically, you can define your own extension that can resolve parameters. And this is a very powerful concept. So, for example, if you had a rule previously that created a temporary directory for you, you could now do this as a parameter resolver and inject that directory into your test method. All right, so this is our roadmap. We are currently almost at M5, so we'll introduce dynamic containers and do some minor API changes, and then M6 will focus on Java 9 compatibility. We hope to get some additional features in, but we have to see how much time we can find. We really want to ship the GA in August, so it's been almost 2 years we've been working on this, mostly in our free time. So we want to have one release candidate before that, but we don't expect that we need two. So it's really well tested, and we have gotten some feedback in the meantime, and we think it should be ready. Good. Why should you care? So I think we have really a good programming model that's really modern, uses lambdas, and lets you write your tests and gets out of your way. We have really powerful extension points, and you can compose extensions. You can declare and register any number of extensions, and they will all be called. And we provide a really gentle migration path. You can run your old tests, your new tests in the same test run. You don't have to do 2 test runs or anything. You can then start writing new tests in Jupyter. There's already good tool support, so IDEA at least supports it very well. You can use Gradle or Maven to execute them. And I mean, Eclipse support at least is around the corner, so it should not be a big issue anymore. And this platform is really flexible. So if you have your own testing framework or idea about how this should look like, you can just implement the test engine interface and then run your own test framework on the platform without any IDE having to know about your tool, about your testing framework. Yeah, so getting started is really easy. We have sample projects for Gradle and for Maven. They're also on GitHub. The user guide is quite extensive. We update that as we go. So we have that as a definition of done criteria for our GitHub issues. We have updated the user guide before we declare this done. Of course, there's JavaDoc if you want to know more details. What we want from you is feedback. So we have a Twitter account. If you don't have much time, just ping us there. But otherwise, please open an issue if you find any bug or have any idea what should be improved. We're happy to discuss it. Of course, remember, this is mostly a project that is done in our free times. So it's not something we can really give you great support, answer immediately, but we will eventually answer. So I can assure you of that. All right, so I'm done. Just in time, I think. So thank you.